Today's video is about COYOTE, a fully automatic white box unit testing tool. COYOTE is a testing tool designed for C and C++. Before we get into the video, let me briefly introduce COYOTE. COYOTE is a tool that automatically creates a test environment, test case, stub, driver for each function and measures the execution percentage for each executed line and quarter based on this. Through the coverage derived from these tests, you can check whether the code is working normally or not, and you can write more secure code. The unique advantage of COYOTE is that it calculates the execution path through a technique called symbolic testing. Since test cases are assigned according to the calculation results, it executes more efficiently than tests in which test cases are given at random. Now we will create a project and test it out. COYOTE creates a project like Visual Studio and conducts the test. COYOTE requires GCC CLang options such as macro, include path, since it runs tests by building actual source codes. If you do not need these options, simply create by dragging and dropping the source code folder. The project created through this sets the settings in detailed settings as default values. The project we will test has simple build information, so we will test it without setting up. When project creation is completed, the following page is displayed. File selection allows you to select files to be tested. After making all selections, we will conduct the test. Click Start to execute all builds. This is the process of performing the pre-work required for the build in advance. When the pre-build is complete, you can select function. Only the functions selected here are tested. If you expand the tree, you can check that the functions are displayed. After selecting all, click Start again to proceed with the build. A build is the creation of a test binary file. When the build is finished, the test will proceed. In the test process, a test case is created and a function is executed with the generated test case to calculate the coverage of the execution result. The calculated coverage can be checked in Overview, Coverage at the bottom. Test results can be checked on the metric page of the left tab. On the metrics page, you can check the total line, branch coverage, or the number of errors that occurred during test execution. The line coverage of the current project is 100%, and the branch coverage is 98.96%. A total of 441 test cases were created during the project, and the number of successful cases was 357. Also, cases where errors occurred during execution, such as 49 null pointer accesses and 31 segmentation faults, are displayed separately. You can save the test results as a report. The format supports CSV, HTML, and Excel. The HTML report shows the coverage information for functions and files. The CSV report also shows coverage information for files and functions. The Excel report includes detailed information such as error location, source code, and coverage information during testing. You can check the results of each file and each function by clicking the Review button in the upper left corner. As shown on the metrics page, most of the files satisfy 100% coverage. If you click a function on the review page, the test case window on the right shows whether the test succeeded or failed. If it failed, you can click the test case fail icon to check where the error occurred. If you look at the Make Families function, it indicates a case where a timeout error occurred because the for loop does not end. In addition, you can check where the error occurred, such as null access. Now, let's check how the test case is created with the operator function in the example file. There is a branch statement on line 130. Let's check how the test case was created to cover this branch statement. The value used in the if statement is the parameter of the todays of this function and offset, and the value used in the branch is used to create a test case. You can check the created test cases in the right window, and as you can see, it's created in the 4th row. The characteristic of COYOTE is that when calling functions implemented in the same file, the prototype function is called. So, toDays of this function calls toDays of date class function declared in the file. If you look at line 101 of the toDays of date class function, the value of this day, a field variable of the date class, is inserted into the result variable, which is the return value of d, and as you can see, the value is created as a test case of the field variable this.day. After that, the value returned by the calculation is less than -2, so the false value is satisfied. As for the true condition, a test case with values of 0 and 0 was created in the 3rd row of the test case, and the result was added to the result by calculation, so line 130 satisfies the true condition. In this way, COYOTE decides which path to search for in each branch statement and creates test cases to search that path. Depending on complex calculation formulas or specific cases, there may be areas that are not covered by automatic testing alone. Manual tests such as stubs and drivers are also supported to satisfy these uncovered areas. If you look at the file, you can check that the true condition of branch 48 is not covered. The cause is that the size of strvec function and the capacity of strvec function do not return the same value. To satisfy these conditions, a user stub is written. Here, a stub is a shell function that only looks at the parameters and return values of a specific function and makes it possible to return only the necessary values. Click the plus button in test case to make a user stub. This will open function settings. In function list, you can check which function was used in which line, whether the stub function, stub, or the original function, orig, was called. If you check the capacity function and size function, which are the functions used in line 48, you can check that the prototype function declared in lines 33 and 34 was called. Click to copy the function name, which you can use to find it in the stub template. Make it into a stub. Write the return type of the prototype function in fill return type, and write the parameters of the prototype function in fill params. Each function returns a size_t data type. There is no parameter, but in the case of a class function, a pointer type of class self is put as the first parameter. The return value returned the same value because only the same value needs to be returned. Make the size function in the same way. After clicking the OK button, go to the test page and run the test again. Only the set function settings will proceed with the build again. If the build is successful, the test proceeds. This is what it looks like after the test is conducted. You can check that the true condition of line 48 is covered. The following is the operator function in this file. In line 87, the false condition was not covered because the self-class this and RHS entered as parameters did not satisfy the same case. Use a driver to cover it. A driver is the caller that calls the function to be tested. It is mainly used when you need to directly manipulate global variables or parameters. As with the stub, write the prototype function parameters in fill return type and the return type of the prototype function in fill params. The return type of the function is date star type. The self class is date star, and the parameter is also date star. The address value of the self class and the parameter only needs to be the same, so create an object with new and then put all self in the parameter. After that, go to the test page and conduct the test. As the test is run, as you can see, you can check that false number 87 is covered. Other than manual testing, there is a way to test by creating a test case by the user. Now let's create a test case directly targeting operator in this file. As an example, if you insert a value of 999 into day of index 0 in the array of LHS and click the Run button in the upper right corner, then the test case created by the user is executed. If a certain line is not covered, you can test it by creating a test case as we just showed. I hope you have a better understanding of how COYOTE works. Thank you.